All Things Data podcast. In the spirit of Daniel Kahneman, Peter Diamandis, and Google Moonshots, brings together leading data scientists, technologists, business model experts, and futurists to discuss how to utilize, harness, and deploy data science and data-driven strategies to enable digital transformation. The hosts are Dr. Manjeet Rege, Associate Professor of Data Science, and Dan Yarmala, Director of Business Development of IoT and Data Science. The podcast is produced by the Graduate Programs of Software of the University of St. Thomas in St. Paul, Minnesota.
Okay, Kirk, welcome to the All Things Data podcast.
Thank you. Good to be here.
Dr. Kirk Borne is the principal data scientist and an executive advisor at Booz Allen Hamilton management consulting firm since 2015. He advises and consults with numerous organizations, agencies, and partners in the use of data and analytics for discovery, decision support, and innovation. Previously, he was professor at George Mason University for 12 years, where he did research, taught, and advised students in data science, machine learning, and data ethics. Prior to that, Kirk spent nearly 20 years supporting data system activities on NASA space science research programs, including a role at NASA's Data Archive Project Scientist for the Hubble Space Telescope. Wow, great background, Kirk, and we really appreciate you being on the podcast.
All Things Data, that describes my life, so I'm really glad to be here.
So, Kirk, you've had a fascinating journey, moving from astrophysics and then recently into data science. Can you talk us through that journey? I mean, how did you prepare for your current job today?
Well, the process, I guess you would say, is a lifelong journey. As an astrophysicist, started grad school 40 years ago. Of course, was doing data analysis, as any good science student would do. Always working with data. I was doing a lot of modeling and simulation. So basically, those types of skills were just a natural part of what I did every day and part of my training as a PhD in astronomy. Once I got out of graduate school, I started working at NASA, and the projects that I ended up working on were primarily around the large data systems, first with the Hubble Space Telescope, and then with a larger facility at NASA, which was the Astronomy Data Center, and which had like 15,000 different experiments from NASA space missions that were related to space science and astrophysics. And so working with all of these different data sets, it became clear after a while that the sizes of these data sets were growing astronomically. And this was like 20 years ago. It really dawned on me that we needed to do something more than just traditional data analysis. Mm-hmm. So I started investigating data mining and machine learning, and was really fascinated by that set of algorithms and that approach to using data. So it wasn't just analyzing the data to answer the question you've already had, but to explore the data to discover new things in the data, new questions you might want to ask. So I became really fascinated, started learning a lot more about machine learning algorithms, data mining, and all of these things almost 20 years ago. And as a consequence, I started talking with other people as I was learning about these things and going to some of the bigger data mining conferences, for example, the IEEE conference, the SIAM conference, the ACM conference, and meeting a lot of people from other disciplines. There weren't many astronomers going to those meetings, and discovered that the whole rest of the world was being overrun by data. So I really sort of dedicated myself to learning more, and not only that, but training the next generation to learn about data and data science, machine learning, because even then it was clear that everybody would have a future that somehow touched data and information. And so I left NASA after 18 years to join George Mason University in 2003. That was already 14 years ago, and we started the world's first undergraduate data science degree program. They already had a PhD program in data science. It was called computational informatics, and I taught in that program. So basically my career path, I was always around data and modeling and simulation. It just the application of all those things was first astronomy, and now the application is just about everything else in the known universe.
So in your current role at Booz Allen Hamilton, I was looking at some of your articles. You've talked about applying machine learning to marketing, because now being a part of a management consulting firm, most of the work that you're doing is more customer driven and bottom line driven, right? So can you talk about some of the applications of AI/machine learning to marketing, for example?
I guess I'm sort of drawn to marketing because to me, it's almost like a surrogate for many other applications. And by that, I mean marketing, and especially digital marketing, is basically the application of analytics to understand what a shopper or a consumer is looking for, what they need at any given moment in time, based upon the data to identify those trends and interests and intents of the consumer. Now, in fact, in my current job at Booz Allen, I'm not doing any digital marketing work at all, but we're doing work with healthcare agencies. We're doing work with cybersecurity projects. We're doing work working with the military and other domains. The common thread through all this is there's a human in the loop, right? There's a person or a set of persons who have intents, who have desires, who have interests, take actions based upon those intents and desires and interests. Then usually you can tell some of this stuff, you can infer some of this stuff, I should say, from the data that we have about that person's behavior and things that they do in the digital domain. And so working on the side, so to speak, I'm writing blogs and articles about digital marketing because it's sort of a generalization, I'd say, a generalization of human behavior analytics, in that case specifically to marketing, but all the concepts of machine learning and AI that we apply there, we're also applying to patient journey, employee journey, and also cyber actor journey, as well as customer journey. So there's so many parallels that it becomes easier to focus on one domain like marketing and just apply it and extend it when we're working with clients who aren't marketing clients, which basically none of our clients are marketing clients. I'm extending the concepts into their domain, and it still works because we're all human.
Right. When you think about context-aware marketing, are there specific machine learning algorithms in your experience that have worked out better compared to others?
Basically, it means including the contextual information, as well as sort of the signal itself. So you might have a signal, and let me pick an example like the stock market. So you can look at the price of a stock, goes up, goes down, and has certain behaviors. And if you just look at that single price of a stock as a time series, then there's all kinds of time series analysis books that you can, help you to understand behaviors and maybe even predict what's going to happen next in that time series. But when you add context, that is what's going on in the world, what's going on at this time of day, what's going on at that location, what's going on with that company, what's going on with that person, all that extra contextual information now helps you to build a better predictive model, a better model to understand that time series. So context-aware machine learning is not really using different algorithms, it's just using different data sets. But sometimes those data sets are not numeric data sets. Sometimes, they're text data sets. For example, someone's social sentiment, someone's purchase histories may be reflected in the comments they're making on social media, on like Facebook or Twitter or Instagram. They may be making some comment about a product they like or that they hate, or that they're going to a certain sporting event or a certain entertainment event, and therefore they might be more interested in buying or selling a different kind of product. Sort of the behaviors, intents, and intentions of an individual is not just the most obvious signal they're giving off, for example, your purchase history on Amazon, but also the contextual information, like, well, when did you buy that? Are you buying those products during the workday, so it's something you buy for work? Is it something you buy on vacation, so it's something related to your vacation interests? So all of a sudden you can build a better, more hyper-personalized experience for that consumer, knowing that extra contextual information, which is, again, beyond just the simple time series that you might have started with. And so, sort of to deal with that contextual information when it's not numeric, like say a social media post, you need things like natural language processing to maybe do sentiment analysis to see if you're talking about a particular product or a particular sports team, are you expressing a positive or negative sentiment about that thing? Right. And so you need natural language processing. And one of the techniques I love to use is association mining. So association mining is historically market basket analysis. So again, it sounds like a marketing thing. What products?
Yeah, exactly.
Right. People who buy peanut butter tend to buy jam and bread at the same time, for example. Right. But you can do that same kind of association analysis with other features about people. Are they talking about product X? Are they talking about something in the business world or in the sports world? Make that association with other elements of data that you might have, and then find what's the strongest association among all those different data elements.
And especially when it comes to market basket, if you buy product X, you might end up buying product Y 100% of the times. But if you buy product Y first, you might come back to the store the next day only 50% of the times and buy product X, right? So there's also some kind of direction there.
Right. So there's a famous case, of course, I'm sure you know this famous case of the beer and diapers that is in all the data mining textbooks. And so the famous apocryphal story is that men who go to the store to buy diapers tend to buy baby diapers. They also tend to buy beer at the same time. But the converse of that is not true. That is, it's not true that most of the time men go to the store to buy beer. They don't tend to buy diapers at the same time. So it is a directional, conditional probability. So again, association mining has directional and conditional probability in the same way as like a Bayes inference has conditional probabilities. And so understanding that sometimes the causal arrow points in one direction and not the other is again part of the discovery process using these types of techniques.
Kirk, going back to the machine learning and marketing, maybe you could talk a little bit about, your thoughts on sentiment analysis as well as behavioral analytics, as we're seeing social media become more and more, a strong ROI with regards to getting consumer insight versus traditionally being, marketers using SEO, for example.
If you think about search engine and keyword placement and things like that, you're basically just already sort of catering to someone searching for a particular thing. In a sense, it's almost further down the funnel, if you will, that the person is already interested in that. But how do you make a person aware of your product? So that's earlier on in that marketing funnel, building awareness of your product in the marketplace. And so part of that behavioral analytics is realizing that there's certain characteristics of human behaviors. That is, again, I refer back to let's say there's some major sports event, and they're probably more likely to buy a product related to their sports team if their team is in the championship. And so knowing that someone is talking about that sports team on their social media pages gives you insight into that person might actually be interested in your product. So you can, so if you think about sort of ad placement or boosted ads, so to speak, on web pages, there should be something that is using that additional information about what the consumer is interested in that moves that type of ad closer to the top of their page, so to speak. The use of this additional insight about, again, people and consumers is just an example of people. Again, medical, if someone's doing medical searches on particular topics, maybe they're anticipating having a surgery or they actually have a particular diagnosis that they're trying to find information on. So again, you can move, sort of content, products, things like that, articles to the top of the list to help that person find the things that are more relevant to their needs. So machine learning can help find, like, for example, doing topic modeling. If someone's looking at a lot of different web pages, what are the topics that are emerging out of the collection of things that a given person is interested in? And so doing that topic modeling helps you understand, this person's really interested in, this topic or this type of event or this type of activity, and that helps you very much in terms of sort of moving the needle, so to speak. Now, the same thing, of course, happens generally in behavioral analytics, where you understand that human behaviors are driven by certain needs. I mean, people are they want to get ahead in life, they want to have success in life. There's even this thing in marketing called FOMO, fear of missing out. So if you think everybody is buying this latest cool music album or this latest cool app, you want to make sure that you get it too. And so, so understanding that people are motivated by that kind of thing also helps to, sort of move, product options, in front of the digital user. And I say digital user generally, again, it's not just a consumer discussion. It's just a general human behavior discussion.
Kirk, one area that I'd like to go into is dimensionality reduction. I'm going to ask, like, how do you, when you're reducing down the dimensions of variables or feature set versus pattern exploration, when you're really looking at, say, massive industrial data sets, you're trying to look at some predictors that are outside the norm and the normative, data that's been around for decades to look at some new nuances. So how do you balance both reducing the number of variables, but at the same time being very exploratory?
That's where data science comes in. And by that, I mean, I always tell people data science is about two things, the two most important things, data and science. And so the science side of that discussion means that it is exploratory. You test different hypotheses. You test different combinations of the variables to see what becomes important. So let's just give an example. So if you have a very high dimensional data set, many columns in a database, if you want to think of it that way. Some of those columns might be exactly collinear. That is, they completely track one another. So a simple example of that might be date of birth and age. Okay, so if you have two columns for the people in your database, and one of them is date of birth and the other one is age, and those things are exactly one-to-one linear correspondence. And when you find those exact collinear dependencies, then you easily remove one of those two because they're basically tracking the same thing. There's no really new information, and in fact, it's statistically incorrect because it's now, if you include both of those things in your model, you're basically double weighting that one attribute when maybe you shouldn't be. And so that's one way of doing it. Another way of doing it is do like principal component analysis, where you find what are the sort of the natural variables in your space. So it might be 100 dimensions, but really all the action is in 3 or 4 of those dimensions. Everything else is just sort of distributed in some normal distribution, or in a non-informative distribution, let's say. So you really focus on those subdimensions, and those subdimensions might not actually be the actual columns in the database. It might be some linear or even nonlinear combination of the columns. So it might be A plus 1/2 B plus 2/3 C times D. That new variable might be the one that gives you the most information about behavior in that database. So, for example, if you're predicting a time series, what's the behavior of an output variable? Let's say you're predicting the price of a stock. It might be some interesting combination of all these other stocks, but once you find that other combination, that becomes just one new variable. So in the same way, a principal component analysis might find the top 2 or 3 dimensions in your high dimensional space, but those new dimensions are some linear combination of the columns in the table. That becomes, again, a scientific process. So data science being that discovery and scientific process, you test different dimensions to find the ones which are either collinear or can be reducible because they either contain useful information, as the principal component analysis would indicate, or they contain no information. That is, the entropy of the variable is so high that it doesn't inform you about anything. Just say you're selling socks to people and you want to decide what color socks to offer to your consumer, and you find out people like black socks, especially on business days, and the preference is neither high nor low, male versus female shoppers. Okay, so there's no point in even including the gender of the consumer in your model, because it might be that they equally prefer or unprefer black socks. And so again, even you find that there's these attributes that contain no information, then you do these different techniques of information gain and entropy calculations to find out that they're just not informative.
And just to add further to your comment, Kirk, in terms of principal component analysis, that is one of the techniques to reduce the dimensions. In addition, one could also do something like multidimensional scaling, right? Because with PCA, what happens is you are trying to project the data in the direction of the largest spread, as opposed to with a multidimensional scaling, you're trying to preserve the similarity that exists between any 2 pairwise data points. So if they happen to be far apart in the higher dimensional space, that would still be maintained in the lower dimensional space, right?
Exactly, yes.
Just to go back to what Dan said earlier, I think the effort of reducing the dimensions as well as the exploration, in fact, one can lead to the other. That is, if you reduce your dimensions down the right number of dimensions, and if you do it in the right manner, that is perhaps not too lossy, then it can lead to better exploration. So a good dimensional reduction can lead to a very good exploration further. On the other hand, if you have a very lossy reduction in the dimensions, your exploration can get affected as well.
Exactly, because if you're basically removing information content from the data, yes, then you've really damaged your ability to explore the data.
Right.
So another example that I really like to use, even though it is probably not one of the better ones, because it's random forests. And by that, when I say not necessarily one of the better ones, because it basically looks at individual attributes as opposed to combinations of attributes. So basically, in a random forest, you build a decision tree based upon the features in your database, and then you sort of one by one just sort of take one of the columns and completely randomize all the entries in that column, so that the entries are no longer associated with the actual row; they're just completely randomized. And if the accuracy of the model, when you build a decision tree off of that data, if the accuracy doesn't change at all in terms of predicting different classes, then that means that column carries no information about classification of those particular classes. So when you do that process, you can sort of measure the change of accuracy of your decision tree, and you can rank the change of accuracy by the attributes, and the attributes that have the least change in accuracy are the ones you want to throw away, and the ones that have the most change in accuracy, that is suddenly the accuracy of your decision tree gets really bad, then hey, that attribute must have been pretty important, because now that I've randomized it, I've really damaged the accuracy of the model. Of course, no one ever discusses, I don't think, in the textbooks, what happens if your accuracy improves when you randomize the data. That would be kind of a scary thing.
Right.
But of course, that won't happen except just in a random sort of way, because if it's truly randomizing the data, then such an outcome would just be a random occurrence. So,
I also wanted to have your view, Kirk, on, we spoke about using machine learning to improve customer experience. So if Amazon recommends a new product to me based on what I previously bought, or based on what I've been browsing, that really helps me to make a further purchase. But there is a thin line there too, right? Because a customer shouldn't be feeling as if he's being watched too much or he's being monitored too much. So if you make recommendations, it should not be over recommending as well, to a point where a person really feels as if he's being watched too much. What's your opinion on that? Where is that sweet spot in terms of not crossing the line?
So that's a really important point, and this is sort of where the discussion around data ethics comes into play, and that is, where's the line between personal and personalization? I think the way you sort of solve that problem is by recognizing you need a human in the loop. So let me give you an example. I mean, most of the recommendations on Amazon or Netflix or any other e-commerce website, which most of them now have these recommenders, right? Most of those do it automatically. There's an automatic machine learning algorithm that does it. Which of course they have to have it, because those e-commerce sites probably get hundreds of millions of visitors every day. They couldn't possibly have one of their staff hand tuning those recommendations. But they should have some kind of feedback mechanism built in, so that, for example, if there's an awful lot of recommendations of a particular product or kind of recommendation that never gets clicked on, maybe it's because it's turning the consumer off. Or even worse, let's say that one of the challenges of e-commerce sites are abandoned market baskets, right? People put things in the shopping cart, but then they never check out and actually buy the product. And so if there's a lot of abandoned shopping carts that can be identified with the occurrence of a certain type of recommended product or recommendation, then maybe there's an association. Again, thinking about association mining, maybe something that you recommended to that consumer completely turned them off and drove them away, so much so that they didn't even buy the other things that they were intending to buy. And so you need to have that kind of sort of real-time dynamic analysis of how is this working out. I mean, is it actually being productive, which means personalization is positive, or is it not being productive, that is, it's becoming too personal? And then of course, once you identify that, then you need to take steps to understand why and correct it. And so I think that there's no easy solution in the machine learning space. It's basically a human problem. That is, the human has to understand, well, what is it that we're doing here that's getting too personal with people, and then back off from doing it. Or even before you deploy it, I mean, of course, you have to do a lot of internal testing. And I always think it's great to do internal testing with your own employees and say, well, do you think this is good or bad? And if people give you feedback and say, oh, no, this is crossing the line, then you better listen.
Right.
Well, I listened to an interesting discussion recently where Facebook gives them some control to turn it on or turn it off, some things that they're experimenting with. So there's some stopgap measures I think one can employ.
Exactly.
And we would think that the machine learning feedback loop would provide some information that they're not clicking on those things eventually, right? So
yeah, exactly. Well, I think that is probably already in their metrics, but the thing is, the metrics themselves can be automatically mined by machine learning algorithms. But I'm saying not only should that be happening, but they should have their, the staff of the company saying, well, we're getting a lot of sort of negative feedback or zero clicks on this particular set of offers. We need to understand what it is we're doing wrong here.
So I kind of want to pivot to kind of more of an applied data science, or where the value is, because I'm one of those guys that was an MBA and then went back for a graduate degree in data science, particularly to see where those tools can be employed. Not that I was going to particularly code, but where could we deploy those things? And this is really well evidenced in that great book that your colleague wrote, The Mathematical Corporation, with Josh and Angela. And, what are the right questions to ask, and how business should drive these things as opposed to data scientists driving, the push versus pull. What's your feelings on that in terms of, it could be from an educational perspective when you're talking to aspiring young guys, or you could take it from a real world example?
Yeah, well, I think that there's a lot of really excellent concepts in what you just said. So maybe I'll bounce around a little bit. So certainly when I was teaching the university, and even now at Booz Allen, I do some mentoring of our younger data scientists. When people just sort of finish school, and I was in this case myself years ago, I mean, you have a lot of book knowledge, you have a lot of learning, you could probably code really well, all this math and algorithms and cool stuff, but you don't quite yet know how that works in a real business setting. And when I say business, I mean even the business of science, because all of my first 20 years or actually first 28 years in life was always in academic research type of labs or institutions. And even then we were working to serve the science community. So if we generated an algorithm or a piece of software or a data product and tried to push it out onto the science community, say, hey, you should really love this. Well, unless we did some kind of user requirements analysis and understanding what the end user really was looking for, that could just fall on deaf ears. No, some people will just ignore it. And believe me, I've lived through some of those things where we built it and nobody came. So understanding what people want is that push versus pull becomes very critical, especially in data science. If you're building, let's say, machine learning models that don't answer the question that the business person has, then it's going to be ignored. I mean, if you're not answering a question that someone needs answered, then you're not helping. But there's the flip side of that coin, and that is there's new questions that sort of reveal themselves as you explore data. And I call that the cognitive side of data science. And so in cognitive data science, I would describe that as question generation. That is, what are the patterns, trends, anomalies, outliers, or whatever that are in my data set that are unusual, that are unexpected, that don't follow the trend and pattern of what I already know about my data. And maybe that's the question I should be asking. Why is this outlier here? Why is this trend all of a sudden changing? Why is there a sudden dip here when it used not to be there? So these questions that get generated from the patterns in the data, in some sense, it can be automated through machine learning. The machine learning can say, I will help you find the patterns that are completely different, or the trends that are completely different. Or as I like to call it, the change of the stationarity of the data. So the data has certain patterns in it. For example, a time series may go up and down and up and down. So it's completely variable all the time. But if it continues to vary in exactly the same way, then there's no information there. But if it suddenly goes up and down twice as fast or twice as slow, or to a higher max or a lower minimum than you've ever seen before, then the question needs to be asked, why is it behaving that way? The generation and answering of business questions sort of becomes the be-all and end-all of actually applying this stuff in the real world. That is, are you really answering a question someone needs answered? And at the same time, can you find these places where really new questions need to be answered, and you can bring that forward to the business? So one example I heard of once was a company that was just basically using a standard dashboard business reporting tool, which in hindsight, it was doing nothing more than just descriptive analytics. It was telling you what happened in the past. It just, the sales of so many gadgets and widgets, in different regions of the country, and they were just tracking their sales figures for last year and last business quarter and stuff. And they weren't really it wasn't really forward-looking, like building a predictive model, which is now more companies are doing the predictive model. But even in that descriptive diagnostic phase of looking at the dashboard, there was sort of a dip in one of the regions of sales in this, like say the southwest region of the country, something like that. I don't remember exactly which region, but let's just say southwest region of the country. There was a dip in sales, and they just sort of the initial reaction was, oh, our sales are down in the southwest, and then you just sort of move on to the next discussion. But then someone said, well, wait a minute, let's drill down into this data. That wasn't a typical thing to do, is to question why there was a sales dip there. The business question, why is there a sales dip there? But there might have been a data reason why there's a sales dip there, and it turns out there was. When they drilled down, they discovered that one of the more profitable cities within their database, and again, I don't even remember the name, we just didn't report their numbers for the quarter. I mean, it was just zero sales for the entire business quarter. Okay, so once you aggregate hundreds, if not thousands, of cities into a sum, it's not all that noticeable, other than this little dip. But as it turned out, there were sales in that city. They just didn't get reported into the database. And so once that correction was made, all of a sudden the sales numbers for that business quarter were just fine. So again, it was question generation. Why is this dip here? Let's explore deeper into the data to understand why is there a dip here. And that led to an insight, which is there was sort of a failure in the data transmission from that particular region into the regional office numbers.
I think you're touching on an important point, because the way I've kind of viewed things was, okay, we have to know the right business question to generate value. In that case, that's driving the exploration in the data science. But you're right, there's this yin and the yang, where the business or the value question, whatever it may be, if it's of social value, has to push forward to set the major hypothesis, let's say, and then the science is moving forward to answer some of those questions and back it up. But if this data science comes back, as you're saying, that is interesting anomalies, the executive has to be able to listen and embrace that nuance, and then that might lead to new business models, as we know, as what we call digital transformation, right? So it suggests that data scientists are going to have to become more business minded, and business people and executives are going to have to become more analytical.